Hello, my name's the Cynical Portal, and welcome to my next YouTube video. This one is a little bit different. I decided that I could start a series where I review different stuff that I buy, different items, you name it. This one, because I'm a huge fan of science, is I got it for a present from my grandparents for Christmas. Happy New Year's, by the way. Here's my it says molecular student set. It has a bunch of parts inside of it, and you can attach them together to create models of different molecules. So a molecule, in case you didn't notice, I'm going to turn this a little bit. Atoms are made from particles, right? As they create atoms, atoms are what create molecules. And molecules, you can also call them compounds. So I got a little list. I know you can't really see it, but you see all these different colors right here. And then you got the different color parts and stuff. You got the pieces that attach them together. Yeah, they're just called connectors. It literally says it on here. These are the different elements themselves. These are the actual atoms. They're represented by spheres. And this is the part that goes in. It's kind of like Legos a little bit. So I'm going to read it off. I'm going to tell you hydrogen is the white ones. So hydrogen is this right here. A little bit smaller, I noticed, than the oxygen. Which makes sense because I think it's actually like that to begin with. Carbon is black. Carbon is the sixth element. Hydrogen, as you know, is the first element of the periodic table. Oxygen is the eighth element. This is oxygen, the red one. Kind of looks orange on here, but it's red. In real life, it's red. Looks like I'm holding one of those mini grape tomatoes. Nitrogen is blue. Not to be confused, there's two different colors. So these are different elements, but this is nitrogen, the lighter one right here. Sulfur is yellow. Okay, so this is sulfur, the yellow one right here. Purple is phosphorus. So this is phosphorus right here. Green is chlorine. Fitting. Dark blue is bromine. These are some interesting elements to work with. Bromine is the dark blue one. If you're wondering why they don't have helium in here, is because helium actually doesn't really like to bond with elements much. Metal, I guess this could represent like any metallic. So say if you have like iron or something. So it could be iron, zinc, copper, gold, whatever. Any metal could be represented by this. We have a p orbital here. This is represented by a p orbital. We have the small connectors, very small, hard to see. We have the medium connectors, which are a bit different. We have the long connectors, which is this part. Oops, shoot, I dropped it. But yeah. And then we have the molecular tool, which I'm not sure what this does. Yeah, molecular tool right here. So I'm gonna try to make a model kind of like this, and I'm gonna tell you what they are. But first you're gonna have to figure it out. So I have a list actually. I'd actually use this in a future video at some point to represent a lot of things. It'd actually be pretty helpful. To explain what a p orbital is, this is actually pretty important. Atoms do not orbit. Particles and atoms, such as electrons, don't orbit in the way that planets orbit the sun. It's not literally them at the center, protons and neutrons at the center, just kind of staying there and then an electron buzzing around. It's not a very realistic representation of what they are. There's a thing called wave-particle duality, which they're not really spheres, but they're objects, but they're also waves at the same time, such as strings. So that part confuses a lot of people, but we can't wrap our heads around it because it's so small that humans haven't really learned to conceive something. P orbital, pretty much, particle or the electron is orbiting kind of like in this kind of motion or like an infinity kind of loop. So I'm just going to show a crisp example of what this does. These are actually quite hard to put together, but usually a p orbital will look something like this. It'll have both sides to it. So the first molecule I wanted to do, I might actually do a part 2 on this at some point because it might actually be useful to have a part 2 on this. So I'm going to get a carbon atom, one of these right here. I'm going to get an oxygen atom, and I'm going to nicely place them next to each other. So this right here is carbon monoxide. So carbon monoxide is relatively dangerous to humans. If we breathe too much of it in, it can kill us. It's a very simple for these atomic structures to become something rather than a more complex molecule. Metals, right? They make these hexagonal structures. A lot of solid atoms, though, a lot more complicated than that. This is represented by a C and an O. So the atomic formula for this is CO. So if we were to get another one of these, and if I were to put that little piece right there, the connector right there, and if I got this oxygen, it kind of looks like a water atom, but not quite. Instead, there's two oxygens. This is carbon dioxide. Carbon dioxide, we actually have this in our bodies. We breathe it out. We breathe it up and out of our bodies. Trees breathe it in. We breathe it out. We breathe not exactly oxygen. We breathe in oxygen, but not quite. One thing that's never really, when scientists talk about, oh, we breathe in oxygen, well, it's a true statement. We actually only breathe about 20% oxygen, and we breathe about 78% nitrogen. It would kind of make more sense to say we breathe in nitrogen, but that would kind of be going off of a road. And I think it's easier just to represent with oxygen because that's how we all use it. And it's a right statement too. And then 1% is other elements. This right here is a carbon dioxide. So this will be CO2. Difference between carbon monoxide and carbon dioxide is CO and CO2. But because there's two of them, it would be O2. All right, I'm going to do a bit more of a complicated, and this is going to be pain in the ass taking this. Yeah, it's literally lounged in here. That's annoying. I'm doing my best though. I'm really doing my best to get this out. Oh boy. Oh my gosh, I might have to edit this part out. I hate this. Don't you hate when you get like Lego pieces stuck together? It's what that's like. There we go. Finally got it out. I was like, oh dear. So this has a lot more to it, actually. This one contains 3 carbon atoms in it. It's alright. I'm not taking this like super like professionally, so it has like these little antennas, right? Oh, okay. So some of the black carbon atoms, there's different types of them, as you can see. I don't know if you can really see that, but see on the top one, some of them have more holes than the other. That's what I was confused about. Because the one I had, it only had 3 different holes, or 4, so I couldn't really attach them together. And it was just kind of frustrating. So I want to get one with more sides to it for this one. Now it looks something like this. This is the 3 carbon atoms. And if you're a chemistry expert, you might actually know at this point what I'm making. It was kind of confusing to me when I was a kid. It wasn't like astronomy. When we're kids, we're kind of marveled at some of the pictures we look at. So now it looks something like this. It looks like a little weird creature or something. Some of these, they do not. The structure, like when they're making this in the factory or something, almost done here with that part. Kind of, now it looks something like this because it has so many connections, right? So now I'm going to use hydrogen atoms. Fortunately, we got a ton of those in this set. So there's 26 of them. There's only 2 of the sulfur, so fortunately we don't really got a lot of those to work with. And also, if you think about it, if you know what you're doing, you could also you could repurpose and rename these. So say if you wanted to make this named a different atom or something, or type of atom, you could do so. And when I'm done this, I'm going to tell you the name of it right here. So, and this looks pretty dang, to be honest. You did a pretty good job with it. So this, there we go. This right here is a propane atom. It's represented by C3H8. That's its formula name. So this is kind of still a pretty simple structure, but as you can see, it has more complex connections to it. You've seen propane. We've all seen propane. You can buy it at the store. Yeah. Here's a propane atom. Looks pretty cool. The bigger pain is actually going to try to be taking this thing apart, so I'm gonna have to do that for a sec. Okay, the next one is actually, you're probably gonna recognize it. I mean, everyone recognizes this one. It's probably the most famous formula of all of chemistry. So this, surprise surprise, this is a water. It has the Mickey Mouse ears, represented by 1 oxygen in the middle and two hydrogens on the side. So this is H2O, 2 hydrogens, 1 oxygen. Ice is actually pretty interesting because ice actually is far lighter than in its liquid form. Most compounds, it's actually the opposite. So ice actually gets less dense because it actually expands like a sponge in a sense, but on the atomic level. So that's why it's so dangerous having frozen beer, not beer bottles, but water in a beer bottle, because it can cause the glass to explode, because it's literally, the ice is literally trying to force itself outward. It's pretty interesting though, but when it's in liquid form, molecules have a very slight attraction to each other. So the molecules bump into each other and stuff. They kind of stay together. They don't really go apart. You know how you've seen like a raindrop and it kind of forms like a sphere or something, because the atoms are still loosely connected to each other. So it's able to do things like that. But in liquid form, water's not able to do very complex things. The last one I want to do is one you probably know pretty well as well. So this one involves another carbon atom. In nature, hydrogen's very explodey. It's not in the way that fire does, but it is very reactive. Hydrogen is a very reactive but very stable element. But yeah, nuclear fusion, all that stuff is all 100% hydrogen, not 100%, but mostly hydrogen. What I'm talking about is like the sun and all that. So it kind of looks like this now. I've put a long connector on every side. So I got a hydrogen on each side. Chemistry novices and people that actually study chemistry, you probably know what this is. This is methane. A lot of greenhouse related. When things decay, when things rot, they release methane. Essentially, methane is released when things break down. So it could be any sort of organic matter, such as plants, animals, that kind of stuff. But it looks like this. And this sucker right here is what is causing global warming. Which global warming isn't a bad thing. It's just that humans have made it go a lot faster. The world naturally warms up over a course of millions and millions of years, but humans have pretty much turned it on its head, and it's actually us that's the issue. But this is what, yeah. Anyways, so that was my review. Well, not really my review, just kind of a tour of different simplistic molecules you'll probably see thrown around a lot in class. Yeah, this is a pretty cool set. I mean, I think it's really helpful. It has a lot of different stuff in it. But unfortunately, I was not a huge fan of these things right here. I think what this is actually used for, this thing, and I think I figured it out. It's actually, I think it's used to get these things apart. Get this removed from this right here. Yeah, pretty good actually. I think it was worth, I think it was like $15 or something. It wasn't a ridiculous price. I think it's worth its price, to be honest. It could have been $20, $30, $40. Still probably would have gotten it, but like I said, it was a birthday present. I think it was about $15. If you like the video, like, share, and subscribe. If you dislike it, dislike it. I'm gonna post a lot more sciencey related videos because I love science, but I also love Roblox. So don't you worry, I'm not stopping that stuff. See you guys later. Thank you for watching.